of Maryland, HCIL. I know we have a bunch of people, both from the University of Maryland community as well as external visitors. So I'm very happy to welcome you. My name is Nicholas Almquist. I'm a professor in the iSchool here at the University of Maryland, and I'm director of the HCIL. And my great honor today is to introduce the founding director of the HCIL, Ben Shneiderman, who's a professor emeritus, distinguished university professor emeritus at the University of Maryland. And he has, hopefully you all know, he's got a long number of accomplishments. I'm not going to go through all of them, but of course, among them was founding the HCIL in 1983. He's a fellow of the AAAS, the ACM, the IEEE, the NIA, and the National Academy of Engineering. I know he's, in the last year or two, perhaps, we've been working on this intersection between human-computer interaction and artificial intelligence. So I'm really excited to hear his talk today. He'll have to tell you all whether he wants to take questions throughout the talk or just do that at the end, but I'll be moderating the questions at the end as well. We will figure out how that goes. Since it's such a big meeting, we may have to have you all write your questions in the chat window, and I'll moderate them. Anyway, it's my great pleasure to turn the word over to Ben. It's all yours.
Thank you, Nicholas. It's really great. I love watching the participant numbers count up to 83 now, and appreciate, as I said, so many dear colleagues from HCIL, the students, and colleagues from well beyond. So that's great. And yes, I'm going to use the presentation mode. Whoops, here, excuse me. There we go. So yes, HCIL is home base for me, and this community, which I started long ago, is now on its 8th director. Nicholas doing a wonderful job in leading it future in bold new ways and keeping old traditions. Its unique nature of its community, which supports each other. It is, of all the parts, the places I've participated in, it brings the strongest sense where people actually work to help you make your work better. From the clinics that we do, to the practice sessions, to the annual symposium, all those strategies are really what make HCIL such a special place, and I'm happy to say community. I hope many of you know me from the
Sorry, Ben, to barge in. It looks like we don't, you're not in presentation mode. We see your PowerPoint interface.
Yeah, I know. Well, okay, I could go.
Maybe it doesn't matter. Go ahead.
I was doing it that way, but let's see.
That's fine. Sorry, then. Go ahead.
All right, I'll switch to presentation mode. Do you see it? Whoops, let's see. Are you still seeing my screen?
Yeah, now this is correct. Now we see the slides only.
Okay, so, you know, the book is so my calling card over 30 years now in 6th edition, requiring 5 co-authors to tell the story of the huge success of HCI and information visualization. You know, just briefly, and some of you, you know, will know these stories. HCIL is the home of the web link, the idea that certain words are highlighted in a paragraph and you click on them and go somewhere was the work done here, actually in the iSchool building in 1985. Touchscreen keyboards, the tiny touchscreen keyboards on your iPhones and Androids also came from our work where we developed the strategy of liftoff to allow precision touchscreens, which led others to emulate that idea and improve on it. And the idea of tagging, photo tagging, that we had photos which you could have names put on them. So those are easy calling cards, and I hold the patent on that, which has been widely influential. The bulk of the work over the years has been on the visualization. The Spotfire tool began in the early work and paper in the Chi conference in 1985. Company formed in 1997, grew to 200 people, and then was acquired. It continues to go on, but Tableau, our friends at Tableau have certainly made the big mark in making visualization much broader. On the top right, you see the tree maps. That was yesterday's tree map I grabbed from the FinViz application, which showed the current state of the market, which was going up strongly. And you can see the 5 big companies, Microsoft, Apple, Google, Facebook, and Amazon, which more than ever dominate the screen and show a larger fraction. The area for each company is its market capitalization. And Apple reaching close to $2 trillion and Amazon, Microsoft coming close behind are staggering amounts, but those are the kind of impacts that are, that this world has had. The colors indicate the green means rising value over the last day, and red means declining value. So you can see the 11 sectors of the market, and yesterday was a good day for the communication services and electronics, but even within them, Oracle and IBM were struggling, and Cisco as well. On the other hand, the financial sector, the credit services did well, but the diversified banks did poorly, as did insurance companies. And you can see how different sectors respond to the market forces. On the lower left is NodeXL, a network analysis tool, continues to expand and grow, now has a Power BI backend, and the second edition of our book makes it the most widely used network analysis tool for teaching. And on the lower right, the work over the last 10 years about electronic medical records of event flow, now influencing the upsurge of work on event sequence analysis. The recent Viz conference featured a special session on just event sequences, and we see that as a growing topic. So that's where we've come from, but I'm here to look forward, and today is sort of a bold notion of a second Copernican revolution, which I propose is a shift from the putting algorithms and AI and machine performance and algorithm efficiency as the central issue, and humans as secondary. Humans in the loop is the phrase, and that always troubled me as a diminutive term. Humans were not, for me, in the loop. Humans were own the loop, and I wanted to see computers in the loop or AI in the loop. So I think of humans as being central, and I want the technologies to support human creativity, responsibility, innovation, and good work. So that's why I boldly called it a second Copernican revolution. I think it's that grand and historical and shift. It won't be easy to do. There are skeptics and disbelievers, and those who hold on to the old view that algorithms and AI will become the future, and that we have to think only about algorithms and autonomous systems. And I am much more about human control and human management and creativity and responsibility. So that's where we're going. So if I try to define this notion, it's the suggestion that, to repeat old ideas, that the goal is to amplify, augment, enhance, and empower people. I'm not interested in a machine which does what a human does. I'm interested in technologies that amplify human abilities by a factor of 1,000. So, information online through the web and Google search have all done their role in supporting that amplification. Email and text services also enable you to do what 100 years ago only the most prominent leaders of countries were able to do. You can reach 1 million people. You have high school students who have YouTube pages, YouTube videos with 1 million views. Photography, digital cameras will become, my prime example of excellence in design. And we'll talk about that soon. Navigation systems, integrating GPS and giving you choice of directions, and business formation by whether you think Uber or Lyft or eBay or Etsy are ways to advance business, but they amplify the ability of individuals and organizations to do what they want to do. So, my goal here for human-centered AI is to make it reliable, safe, and trustworthy. And that's the title of the first of 4 papers that I've published this year on this topic. It's become a deep passion of mine, a deep commitment. So what we're after, though, is human self-efficacy, creativity, and responsibility. Some interpret a human-centered AI as computers that will become our teammates and collaborators and partners. And I do not see that as a productive way of the future. I think the tools that empower us from dishwashers and dryers and copy machines and heating and HVAC systems, heating, ventilation, and air conditioning. These are tools that empower us, and the visualization tools built at HCIL and elsewhere support us. And that's what we want to see. We want to make people powerful, not dependent on machines. We want to build human self-efficacy, creativity, and responsibility, the open-endedness. And I see people in a very different category than I see machines. I don't believe that social robots are the future. I think they are likely to become the Google glasses of the next decade as people come to understand that there are better ways to design. So if you buy all this, then you will be in line to support human values, rights, and dignity. And that's the higher level abstract notions that bring us to the ethics that we'll come and talk about a little more. So these themes were explored and described in paper, the first paper in the series about reliable, safe, and trustworthy. That paper has received more than 7,000 downloads in its few months out, and that's a strong indication of interest and support for this. It's still a challenge, it's still a minority view, and that's why I'm reaching out to you today to help join that movement to make human-centeredness the goal. So, you know, I was saying these are the kind of designs that I want to see. These seem, I think our AI friends and robotics friends would not see these as robots, yet these are the kind of successful commercial tools that are out there. They're, I would say, low end and don't have all the features that our AI friends would like, but that's, I think, the starting point and the more likely place to expand from. Good control panels on every robot. And we'll talk more about that soon. Now, you know, the journalists love the idea of the independent robot and the idea of robot surgery, and robot surgeons are better than human surgeons. Again, the comparison model is the failing model. When you see people comparing robot performance to human performance, you know that they're on the wrong track. When you talk about empowering people, then you know they're on the right track. And the makers of the main surgical system called DaVinci, whoops, sorry about that. You know, on their webpage, it says, robots don't perform surgery. Your surgeon performs surgery with DaVinci by using instruments that he or she guides via console. So this kind of robot, you know, enables a surgeon to perform precise operations at very difficult to access points within the human body. So these new forms of surgery are often less invasive and have better results. But it is, in my mind, it's more important to see that the design of the user interface for surgeon control is really what we want to talk about, okay? And the Mars rover is often portrayed as autonomous. Well, they are up to a point. They're an excellent example of the combination of autonomous design with human control. The Jet Propulsion Labs Control Center shows you there are dozens of people who are operating the Mars rover, okay? And Houston Ground Control also has dozens of people who are working with visual displays to control, to control the Mars rover. And that blend, the fine-grained understanding of which features can be autonomous and which features should be under human control. Now, typically the autonomous actions are short-term. So the Mars rover can move about and avoid obstacles and so on. But its planning of where it goes, what it does, and management of its own systems are handled over longer time frames by humans. Similarly, what used to be thought of as an autonomous device, a pacemaker placed inside your chest, which operates on its own for long periods of time, is now becoming a operated device. And more medical devices have controls, not just for the patient, not just for the physician, but the aggregated data from the history of 1,000 pacemakers makes for better pacemakers. And similarly is what we have in financial analysis. The Bloomberg Terminal has more than 300,000 people paying $20,000 a month to have this on their desk, because it amplifies their ability to carry out their work in highly, large volumes of money are controlled by the people who understand the patterns of financial movements. Similarly, control centers like this counterterrorism control center show a huge amount of visual information, as well as cooperation among individuals as they take shared actions to respond to cybersecurity or other terrorism threats. And similarly, medical terminals and personal workstations. Sorry, that was my phone. Okay, those all become models for, I think, what we'll see more of in the future. So the content, that's kind of background about what we want, where to go. Maybe I should pause, and Nicholas, if you've got some questions in the chat that you want to raise, let me take a breath and see if anybody wants to respond to that.
Yeah, so we have a bunch of questions here along the way. I'll just take the first one here. Well, let's see here. I'm trying to curate them. Alexander Hervix asks here about the Copernican revolution figure that was shown. And it might be really fruitful to think about what human stands for and what AI stands for. Is it just about humans or robots, or are we maybe talking about narrow and broad perspectives of organization and value?
Whoa, I'm quite interested to hear what Alex has in mind there. I can understand the point that when I talk about algorithms and AI, it's a narrow technical notion. And when I talk about humans, one can see it as a broader and societal concern. And of course, I can see it that way. But I would say, it may be, it emanates from two schools of thinking about how to advance new technologies. One says it's technology driven. You start with the new technologies and you think, what can I do with this technology? How do I improve it? How do I make better robots? Independent of what the applications might be. And there's some power to that. There's some utility to starting with a new technology and trying to enhance it, improve it, make it more efficient, and then wait and see what others come up with applications. That still is a dominant form in computer science and many other fields, but the growing form, I believe, is human-centered, which suggests that you look at human needs, human requirements, and you look at real driving problems and you say, this is what we really need a robot for, whether you think it's elder care or medical attention or construction industries or military or aviation. You look for those problems and you study the users currently and study them in depth, and then you consider what technologies. So I would say that's a concurrent shift. So I support, the theme of that question. Is there another question? Let's take one more.
Yeah, Hernisa is asking about, the role of AI should not be such that should be so that people are not dependent on machines, but we already have a situation where people are dependent on machines. So what is this? Could you expand your views about human-machine interdependency in life?
Fair enough. Yes, we're always dependent on all the machines we have, whether it's our clothes or our tables or our cars or other technologies. We empower ourselves by the technologies that we have. The question is, where does control reside? So I believe that we want to think about human responsibility. That's the central distinguishing feature for me, that only humans are responsible for what happens, and therefore they will insist the machines be at least predictable, controllable, and comprehensible, because they are legally responsible. Machines are never legally responsible, only humans and organizations. So responsibility is the way to clarify what's going on here. And I do think while the tool metaphor is criticized by many who see it as shallow or narrow or limiting, I think it's a better model than the idea of autonomous agent and partner and collaborator. So, I mean, there's lessons to be learned from the themes of autonomy and of collaborator, but there's dangers in going that way. And the dangers become things like, the 737 MAX crashes, where the designers believed they could make such an effective autonomous system that the pilots were not even informed of its presence. And so they did not have adequate knowledge of what to do when it failed. And so I think that failure mode is really important to understand. This is playing out very strongly in the so-called notion of self-driving cars, which as it matures, the designers are realizing this is not working out as well as they hoped. And while I do believe ultimately self-driving cars will be safer, there's still work to be done, and increasing human control, not just by the driver, but by remote operators, by a centralized office, by vehicle-to-vehicle communication. There's a number of things that need to be done. I think it's worth remembering, and maybe I wish I could ask everyone, how many deaths do you think have occurred with Teslas? How many deaths with Teslas? There's the famous one in 2016 that gets a lot of attention. But there's a website with a spreadsheet that has last time I looked, had 149 deaths in Tesla cars. Now, not all of them are responsibility of the human driver or the machine or whatever, but it is instructive to remember that we still don't have, that the level of safety in 100 million miles per driving is still better with humans than it is with the current self-driving cars. But the future self-driving cars, I'm hopeful will get us there. All right, so let me move on. I'm sure there are other questions, but the center part of this talk is to explore how to bridge the gap between ethical principles and practice. There's a huge discussion of ethical principles. There's 400 reports, typically from government agencies, from NGOs, research centers that talk about the ethical issues. The two I would strongly recommend is the Berkman Center on Principles of Ethical AI, and the other one is the IEEE's Ethically Aligned Design, an excellent and 250-page long document. Katie Shilton from the iSchool was one of the participants of the 20 committees and more than 200 people who contributed to making that work. The Ethically Aligned Design paper does give a great set of ethical principles, but it's still, the title is Autonomous and Intelligent Systems. And so there's kind of that duality and the contrast and the conflict and the tension that goes on between these different principles. The Berkman report on principles of AI is a very thorough, very thoughtful review of the key of those 400 reports. It chooses 36 of the most comprehensive ones and gives a very nice summary of all the possibilities. However, all the discussion about ethical design still, to me, is just the foundation for practical work. And the goal of this most recent paper that appeared in the, well, I'll go to the next slide. This is the summary of it in the ACM's TIIS, just appeared last month, the transactions on interactive intelligent systems. I have to thank Michelle Zhu, the editor, for pushing this forward in a good way. And in just a few weeks, it's already gotten good attention of more than 800 downloads, and there is strong growing interest. So in this paper, which I'm trying to summarize in this talk here, there's 3 levels of discussion that push forward from ethical principles to actually the practical decisions that are needed for teams, for organizations that have many teams, and for industries that have many organizations. So that's the 3-level structure that I organized, and I began to see that some of the advice and some of the ideas were more for the software engineers who are actually developing systems and testing them. And then some of the things were organization-wide strategies. I'll talk about those briefly here. And then the sort of larger circle is of the independent oversight that comes from external groups that look at systems. So we'll come to each of those. There are actually 15 recommendations. The first group for the teams has 5. Each one has 5. And I won't go into all of them, but just briefly, I will go in this talk to focus on 2 in this category. The idea of audit trails and analysis tools, come back to in a moment. Software engineering workflows that are being retuned to fit the needs of AI, particularly machine learning and deep learning strategies. Here I'd cite particularly good work from Microsoft people and from Google. Again, many citations in the paper, but these organizations have developed new workflows that are relevant to machine learning and deep learning and its related strategies. I think what's happening also is verification and validation testing is changing. We need to do that at 2 levels, and maybe I'll combine that with the 4th one, bias testing to ensure fairness, because what's fundamentally different about AI algorithms is that you have to validate and verify the algorithm and also the data that goes with it. And the data may be, biased, and the training data is problematic. And so there's real questions that are being explored fruitfully in the AI community about how to do bias testing to ensure fairness. The last topic, explainable AI, or I say explainable user interfaces, often abbreviated as XAI, is another wonderfully growing topic, and I will comment on that and have a different vision. So let's just dive into these 2. The first one about audit trails and analysis tools. Civil aviation has an admirable record of success and safety due in part to the flight data recorder, but also the cockpit voice recorders. These, sometimes called black boxes, are really orange boxes, and they capture a huge amount of data about what's happening in the plane. When a 777 crosses the Atlantic, it generates about a petabyte of data. And so it's a huge amount of data, but what it allows is retrospective analysis in the case of crashes and failures. And these have become extremely valuable. So here the NTSB, the National Transportation Safety Board, is the hero for its independent oversight. And we'll come to that as well, that when a crash happens, their teams of trained and knowledgeable inspectors arrives and they examine what's happened, and they have many tools for doing analysis. And the reports are exemplary in that they describe in huge detail what happened, and then they make a set of recommendations. So actually they did analyze the 2016 crash of the Tesla car that killed the driver, because the Tesla vehicle system did not recognize the white truck. This large truck, tractor trailer truck, was white, and the visual system of the Tesla just saw it as sky and thereby drove right under it, and in a gruesome outcome, decapitated the driver. And this was a person who was famously, loved the automated version of Tesla, but it was a sad story. So in the 60-page report from the National Transportation Safety Board, there's an excellent description of what happened there and 14 recommendations, including better audit trails and analysis tools. So Tesla does record some things and they do some analysis, but the expansion of that was what the NTSB recommended. Now, in my studying flight data recorders, it's been an interesting experience for me because there are lots of patents about flight data recorders, but very little research. Okay, and even under the notion of retrospective analysis of failures, if you go to Google Scholar and you search for these things, you'll find very few. You'll find lots of patents, but not research. And as I became devoted to the idea of audit trails or logging tools for every robot and every AI system, I approached 4 conference technical program chairs in robotics and said, how about adding the idea of audit trails and analysis tools to your topics? And each one of them said no. And then I approached the editor of the journal on social robotics. And I suggested that as a topic. And he said not only no, he said hell no. So there's a real resistance to the recognition that these autonomous systems can fail. And for me, there's a distinction between lightweight recommender systems where a failure or a mistaken recommendation is sometimes interesting. If you get a curious recommendation on your Netflix page, it might be an interesting one. But I'm more concerned about what I call consequential systems, where there might be damage or loss or injury, and of course, life-critical systems in medical, transportation, military, and other applications. And so the idea that every flight data recorder for every robot is my strongest recommendation. It's what I'd like to see happen most. And so I become an advocate of this. In my process of studying this, I spoke to Christopher Hart, the recent chair of the National Transportation Safety Board, and he supported me strongly and added 2 more important comments. That those flight data recorder records, not only are they used for retrospective analysis of failures, but for an understanding of the near misses and the ways in which pilots successfully avoided danger. And so that became a secondary use, but in recent years, that's become a very powerful tool. So could you learn about the good practices of pilots so that you could improve training? I think the answer is yes. Okay, and the even more recent addition for the flight data recorder information is analysis to support preventive maintenance. That the logs of the things that go wrong with these planes, of engines overheating, of wing surfaces that don't move as they should, these all become indicators of problems that you now can understand on an aggregate basis of every 777 that's flying or 787, and you can find out what's been going wrong across the fleet and thereby improve preventive maintenance. So if you take away one thing from this talk, I would say the idea of audit trails and analysis tools, or as I call them, flight data recorder for every robot. Okay, so that's one of the 5. The second for teams is the idea of explainable user interfaces. And I would say here as you may guess, I have a different view than what is currently popular as well. The currently popular approaches seem to repeat the history of 30 years ago when knowledge-based systems, knowledge-based expert systems were introduced, and even HCI online help was introduced. The belief was that you could have post hoc or retrospective explanations. And that means something happens, the user is confused, surprised, uncertain, doesn't know what to do next, and asks for help. Okay? And that idea pervades the huge discussion, thousands of papers on XAI. And the retrospective explanations, the discussions often generate into whether it's local explanations of the particular case or global explanations, whether it's explanations of the way the machine functions in general. And there's a lot of interesting discussion and some productive ideas there as well. However, I would say the history of online help was not to make it better, but to reduce the need for online help, to have comprehensible user interfaces by which there was prospective exploratory use that prevents confusion and surprise. Okay, now this may be a tall order, but let me go through an example. So I just want to say that the real opportunity here, I think, is to clarify what's happening so users of AI systems are not surprised or confused and thereby seeking explanation. So the favorite, white mouse of the topic is the mortgage loan, all right? And I would say another disturbing thing in this huge literature in the AI world is the very few examples of user interfaces of how explanations would be done. So I provide this example here of a post hoc report. You enter amounts to request a mortgage. How much money do you want? What's your monthly household income? What are your liquid assets? And you say submit, and you get feedback. And a post hoc explanation might look like this. We're sorry, your mortgage loan was not approved. You might be approved if you reduce the mortgage amount requested, increase your household monthly income, or increase your liquid assets. So this is better than most systems that are being proposed, which sometimes try to go explain how the deep learning works and how the decision was made. Look at that. My machine has gone autonomously. It sort of jumped ahead on its own. So I propose an alternate view that instead of waiting to get a rejection, that you prevent rejections from ever happening, so you don't need explanations. So you might have a set of sliders where you can slide for the amount requested, slide for the monthly income, and then for your liquid assets. And it would, as you adjust these three yellow triangle sliders, the score would go, and you can see how close you are to the score, and you can explore to see what happens so that you'll know what you need to do in order to attain approval. This is a trivial, simple example with just 3 variables. I know the real models are much more complex, but it's an easy to understand one, and I think shows the promise of what I call exploratory user interfaces, or comprehensible interfaces that prevent confusion. Let me take a breath here and see if anybody wants to challenge this one or tell me of examples where they've seen this idea put to work.
I don't know if we have any questions right now. Let's give it a moment to see if anyone wants to challenge this. There's a few questions from a little earlier, or comments in the chat window here. One is, for example, asking whether you have an example of AI-centered design. This is from Heshan Sun.
Yeah, I would say, the typical designs are the autonomous ones. So I would say this, the Patriot missile system, which incorrectly shot down 1 US fighter jet and 1 British fighter jet during the Iraq wars. Those are kind of famous and deadly ones. I think the autonomous ones, or robots which simply, or even, roam around, but you're not sure what they're going to do next, are the examples I most criticize. What people want most from the design of technology that we use is predictability. And so just as when we drive a normal car, you signal that you're going to go to make a left turn or that you're going to change lanes. So that signaling lets everyone else know what you're about to do. And it would be quite natural that if you had vehicle-to-vehicle communication, that the vehicles could signal that I'm planning, this car is planning to change lanes in about 12 seconds. And so that communication would be the kind of improvement. But I think, I think you want to, so let's just say positive, you want to give much more status and intention of what the computer will do. Is there another question that popped up relevant to
Yeah,
this?
so there's, I think, two. One is relevant to this. I didn't spot this earlier. Christian Kucher asks that, opening this black box would reveal the company's internal rules or scoring schemes to the rest of the world. And this sometimes are, unique selling points. There might be things that are unique to the company. That's what they actually sell. So there's, I guess, a conflict there.
Fair enough. There can be a conflict, but I don't think if we're going to have consequential and life-critical applications, we need to require companies to be more open about it and report about it. Certainly, we expect that in aviation and in automobile as well. So there are real questions about who has access to the flight data record or the audit trail, and who owns that data. Is it owned by the company? And what rights do the company have to protect their strategies? And but I think we're going to expect more of that to become public. In any mature field, take building construction, you have to expose what are the methods you're going to use for electricity, for plumbing, and for construction. That's part of the planning process. So I think the maturity of this will lead that way. You said there was one other?
There's one other. It's just a comment there in your response is that a parallel might be in cryptology, where the practice for the last decades have been you publish your algorithms and you just make so that they can be openly audited and studied. It's just the keys themselves are where you sort of hide, whatever is the cryptology, the secrets.
Nice point. Nice point. Good supportive. I appreciate that. Thank you.
So then the question that Tammy Clegg, she's wondering about the audit trails. Did companies with the patents not do the retrospective failure research, or is it just that they are proprietary, so they don't share it outside of their company?
I'm not sure I gather the patents describe different ways of doing flight data recorders. So they disclosed the methods of flight data recorders and proposed new ones. And I should say there's warm receptivity to this idea in the professional robotics industry. Like I've spoken with the Robotics Industries Association, and they are all behind this idea of, of logging trails and retrospective analysis. But the research community has been slow to pick up on that. I think that's an interesting thing that we need to change. So I'm not sure. Do you think I got to what Tammy was after?
I'm not sure. She hasn't offered any further.
Tammy, do you want to speak up?
Yes, no, I think that helps me understand. I thought you were saying that they had patents, but so the patents were mainly for the process of capturing the retrospective.
Right. What is it that, they're about? How do you instrument an aircraft or a refrigerator to record its performance in ways that are relevant? I think these will be very industry specific, and they will be very different from medical devices. What would the audit trail for a pacemaker or a implanted insulin pump look like? How do we collect? How do we design tools to collect what sensors are needed? So there's a lot of good work to be done. I think there's interesting research there, and I would say I'd like to encourage that. Again, I repeat, my number one message or hope would be this talk would encourage more about flight data recorders. And the second one is this exploratory user interfaces to prevent confusion and reduce the need for explanations. All right, I'm going to move on to the second oval in my the structures here. The idea that organizations, that a company would develop a safety culture so that all of the software engineering teams would be embedded in a world where safety becomes a primary item. And here, that literature, there's 3 or 4 intersecting literatures about cultures of safety and resilience and so on, robustness. There's a variety of terms that have been used, high reliability organizations. So this is more of a business literature. This took me into a very different set of literatures, but the leadership commitment to safety, the consistent and repeated focus of the leaders of an organization to say safety is primary. Now, you know, skeptics will say, well, they'll say that, but they don't really mean it. So how do you know if they mean it? Well, if their hiring and training are oriented to safety. I remember in one case, I was working with nuclear reactor control rooms and the failure there. And when I suggested, they were very proud that they had these elaborate plans for many, many kinds of failures. And they were called fail-safe trees. They were decision trees. And they had hundreds of these. And I asked, you know, I suggested that what was needed was that every operator needs to go through every one of these every 3 months. And they said that would be impossible. And that's when I became to know that it was an unsafe environment, because the operators could not be trained adequately to perform when a safety incident and failure had occurred. So the level of training, the simulations, when hospitals conduct a 2-day exercise for mass casualty training, then I know that's going to be a successful, safe organization. Extensive reporting of failures and near misses, and this is a bit opening up to report on what happened, but we've come to expect that, certainly for aviation, increasingly for medical care. And the good news from a 5-year University of Michigan study showed that when failures were exposed, reported on, and patients who had been harmed by medical failures were offered an apology and either financial or other kind of compensation. Under that model, everybody feared the openness would lead to increased lawsuits and increased problems, but it was just the opposite. By promising open reporting of failures and near misses, the physicians and the nurses and the staff all became obsessed with safety, and the number of failures declined, and the number of lawsuits declined, and the patients who had been harmed, what they wanted most was an apology. They wanted to know that they were poorly treated and that they would then, the compensation was nice, often important for people, but the apology was the essence. So that's, you know, that extensive reporting, and then the complementary internal review boards for problems and for making future plans, and then the alignment with industry standard practices are the ones I think are important. So the capability maturity model, which is used in software engineering, is one such standard, but there are other approaches about safety culture that are not widely known. And I felt in this article pointing to the organizations that do it was a necessary part. So those are what organizations and leaders in organizations can do. It's less of the focus of HCIL, but it seemed to be their opportunities for making future technologies safe. My third oval is the trustworthy certification. I'll spend a few more minutes here on this issue. And I've, in the last 15 years, become a student of independent oversight at the industry level. And I've already mentioned things like government interventions, such as the National Transportation Safety Board, and regulations. Industry worries about regulation limiting innovation, but we know that when regulation is done right, as it was for automobile safety and automobile fuel efficiency, it has a huge trigger for innovation. And so, yes, there are dangers, but I would say that government intervention is a reasonable possibility. The idea of accounting firms, the big four accounting firms conducting external audits, as you may know, the Securities and Exchange Commission requires that all the 10,000 or so publicly listed companies in the US to have an independent annual audit, okay, from external. They have internal audits as well, but they have external audits as well as a necessary part of it. So the big firms, the Arthur Andersen, well, that's the old red days, but KPMG, Deloitte, Ernst & Young, and PricewaterhouseCoopers are the current big four accounting firms that do these external audits. And they are, I'm pleased to say, moving towards working in the AI topic as well. So I do see hope for that possibility to give guidance to firms about how to carry out AI projects. Insurance companies may be stepping up to be the source here, as they are in the building industry. In the building industry, the insurance companies will say, okay, if you follow the building code and you build according to the rules, and the inspector gives you a certificate of occupancy, we will insure your building, okay? And so that became a big driver for improvement. That's also true in transportation and medical fields. And I would like to see insurance companies become independent auditors for industrial AI projects. I'm not talking about startup companies or university research groups, but I'm talking about when a major company like Bank of America says, we're going to have a new mortgage granting program run on an AI system with machine learning, then there should be some kind of independent oversight. I know the companies tell us, oh, we're very careful, we're doing everything to be correct and be fair, but still the independent oversight, I think, becomes a valuable, positive contribution to improving reliability, safety, and trustworthiness. Non-governmental and civil society organizations have a role, and then professional organizations and research institutes as well. I want to just give more generally a discussion about independent oversight. I guess I've mentioned already the corporate internal audit committees with advisory boards, external university accreditation, NSF, you know, the British, the UK, EPSRC. All these advisory boards are forms of independent oversight. It's a widely used method. And zoning boards, planning commissions, and environmental impact reviews are another forms of independent oversight. And then I list several government agencies, and I'm going to say a little more about these here. So there's three forms of independent oversight. One is, I've mentioned, the planning oversight, which happens before projects are done. The second is continuous monitoring. So for example, the US Food and Drug Administration monitors the production of pharmaceuticals and also meatpacking plants. Those are expensive forms of monitoring, of independent oversight, but they have proven to be valuable enough. Similarly, the Federal Reserve Board has someone for every major bank that does monthly analysis of whether they've been fair in granting mortgages. And the most visible one, of course, are the retrospective analysis of disasters. When something terrible happens and the NTSB or a Congressional Investigation Committee steps in to do these kind of analyses. There's a lot of issues in the design of such independent oversight, the degree of independence, subpoena power, and powers to enforce. So if they make recommendations, does it have any teeth? Do they have to be used? I wrote about this early on and proposed a National Algorithms Safety Board, modeled on the Transportation Safety Board. And that short opinion piece appeared and has been influential, and more people are picking up on that idea. So just briefly to just remind you, these three forms: planning oversight. Here's the meeting of a town. The township of Lakewood, New Jersey is meeting. Here's the review board. and someone's proposing a new project, and there may be others who counter it, this adversarial process. There are those reporting what's happened. And so the planning board does its job and makes a decision and then says, okay, there may be adjustments to the builder's plan, but they go forward, and then the inspector comes, gives them a certificate of occupancy, which allows them to go forward. Continuous monitoring, the Federal Reserve Board, I mentioned that example, and its way of continuously monitoring banks and others, and the retrospective analysis of NTSB arriving at an accident scene and doing the review. So I think we'll close here and summarize just to say, the first message, the overriding large, broad metaphor is the Copernican revolution, the shift from algorithmic centered to human-centered. And the second point is, the goal of human-centeredness is to amplify, augment, enhance, and empower people, and thereby support human self-efficacy, creativity, and responsibility, and also make us aware of human values, rights, and dignity. People are not machines. Machines are not people. There is a difference, a categorical difference, which I think will remain so. I believe that people are different, people are special, and we need to respect that, and we need to design technologies to support people. Finally, this diagram does capture this idea of the strategies for bridging from ethics to practice, and that design thinking has to become a much stronger part of the AI community, as well as becomes more, HCI should become more of an AI community. I've been looking, and maybe some of you can help me, for courses at universities where AI and HCI are taught, where machine learning and user interface and visualization. There's about a dozen on the list I have. It's linked from the page, the HCIL page, or I can send you that, but I don't yet, all the cases are of HCI people teaching about AI. I've yet to find a case of an AI-oriented course which teaches HCI and design. So maybe you can help me with that. And I just closed, there was a very nice review of my position in the New York Times in May. You can search on Markov. And the case, he labeled it cooperation between machines and humans. I'm less, well, he gave a very nice portrayal of where I'm at. And so I would encourage you to look at that. And these are the 4 papers that are all open access and available. I've sent the slide deck to Beth Domingo and hope she can post that. If any of you have trouble, please reach out to me and I will send them to you on your own. So thank you. I think I made it to 10:30. I'm happy to stay for a few more questions if people have, but if people need to go, I understand that. Thank you again.
Yeah, we have 2 comments here. I can I can moderate them. And then maybe there's some more questions that will pop up. One was about AI-driven chat bots and conversational user interface. What's your vision about this, perhaps to bridge the gap to exploratory user interfaces?
Yeah, I think it's interesting. I have to say, I am impressed by, Alexa, Amazon Alexa and Siri. The things that have happened have been the remarkable improvement in the accuracy of speech recognition. I was really impressed by how that happened. And secondly, the reasonable capacity for it to deliver a response, often a link or a website usage, and increasingly Siri has become a web search tool where auditory access, and important for those with disabilities, it can be a very helpful tool. I use them. I think they're quite wonderful. So, the question is, how far does it go with that? Those tools, I think, become powerful, but they're carefully monitored by Amazon and Apple. to try to make sure they don't go off the track and do malicious things or say awful things. So I think there's good human oversight of that, and I think they're steadily improving. I think that's fine. I think you want to avoid the belief that they're going to become friends, partners, or, or if you see them that way, I think it goes wrong. Okay, so let's see. I see in the chat John Gersh. Hello, John. What is it about a Mars rover that makes it a tool rather than a teammate? Teams have leaders who delegate subordinates to autonomy. I mean, I think the basic question is it's a tool of the NASA operators in that sense. They are operating the rover and they are getting it to do what they want to do. And there's several levels of the NASA management of the long range view of why are we building rovers? What do we want to get? What tools do we need to build into the rover? And then how to manage its time? Where should it go? And what should the precious resources of battery and of communications be used for? So all those decisions are what the human managers do. I'll say also, no matter how powerful the tools are, like the Mars rover, supercomputers, or the Large Hadron Colliders, all the scientific paper authors are people. And I think it will remain that way because it is people who decide what happens, who take the risks, who make the creative decisions. Okay, I'm seeing a few other things here. I think it's probably time to wrap up. Anything vital, pressing? Thank you for all the good compliments here. Appreciate that. And any last minute, anybody want to jump up and say something to close?
Hi, I just wanted to jump up and say thank you so much, Ben. And I also wanted to make an announcement for next week's talk. I'm very excited to have my good friend and colleague, Sheena Eretz from DePaul University come and speak. And just like Ben was getting us started on talking about policy issues that are that come out of our HCI work, Sheena is gonna kind of go deeper into that as well. Her talk is entitled Countering Structural Oppression Through Co-Design with Residents in Resource-Constrained Communities. And she's gonna be talking about research that she's doing at the city level in Chicago to help low resource communities to prevent crime and to promote learning. So look forward to seeing you all there.
Thanks, Tammy. Yes, I will. I'll be tuning in. So.
And I just want to thank you, Tammy, for doing that. I was going to ask you if you would, and you took care of it. We do have a listserv that goes out that announces all of these. If you want to give me your email address in this chat, I'll add you. Thank you, Tammy. I took care of you. A couple other people during the session have asked. We also tape this each week, and it's available on YouTube, and we do send out notices via Twitter. So we're trying to build some momentum, and congratulations, today is our highest attendance. We had 97 that came in to see the talk today. So thank you very much, Ben. We're very appreciative.
Yep. Thanks, everyone. Great. And thanks, Ben. Definitely.
Great. Thank you all. Appreciate it. I'll look more at the questions and respond maybe to some of you individually, but thanks again for the opportunity.
Hi, Ben. Hi, this is Snehesh. And I read your papers, and I actually had drafted an email, but I never got a chance to send it to you because I was still digesting, because I come from almost like you were saying about there are two schools of thoughts, right? Where one school of thought kind of assigns how do we take the AI perspective of humans and kind of leverage all those understanding and try to build technology around it, kind of thing. And other ones first look at kind of keeping human in the center and what is needed for the human and kind of build based on that. And so one example that you were just mentioning earlier was about how we should not treat AI as a human or replacement of a human or as a teammate, but rather enablers for human. But oftentimes is a famous example of the early chatbot that was created, where is not the creators gave the AI the value of a human, but rather the people who were interacting with the system starting to treat AI like a human. And in that place, how do you strike a balance between creating these agents that at some point, because of the some properties that are like human, the people start to treat them like one, and then how do you strike a balance of that? Could you please comment on that? Thank you.
Right. I think you're referring to the early story about Joe Weizenbaum's Eliza, where people
Yes.
came to see it as a therapist, and Weizenbaum was appalled at this, and that's one reason he shut it down, or its public use. But certainly it's attractive. And of course, Cliff Nass at Stanford and 20 studies with his students show that people are very likely to look at robots and as if they're social. And the whole movement about CASA, computers as social actors, and the journals of human-robot interaction all portray this notion. And yes, it's absolutely true. But what I mean, Nass was a good buddy and sadly died too young. And we love to argue with each other, but Cliff's, I would say it's Nass's fallacy, that just because people are willing to treat a computer system or a robot as another person, as a social, does not mean that that's the best design. So it's a kind of fallacy, it's a trap. And the studies rarely have another treatment, which is a well-designed user interface that gives users control versus one that suggests it's human. But the history of this issue, to me, is very clear. So the early bank machines, the bank tellers, and were designed to be characters, and they were supposed to have a relationship with them. And those are gone because customers reject them. They're very cute and interesting to start with, but what people want is their $60, and they want to do it in as few clicks as possible, and don't want to be distracted by a relationship. Same failure for the postal buddy, and even the intelligent tutor systems are gone. Which respected the learner, gave the learner ability for their own learning, rather than an intelligent tutor with an avatar that told you what to do. And so I think, to me, the history and discussion is very clear that if you want a commercial success, you're going to do better by enable self-efficacy, the accomplishment, rather than who gave me $60 from the bank.
Thank you, Ben. I appreciate it.
Yeah, I'm happy to stay on for those. I think people are leaving. Thank you all for your participation. Dag, are you in Buffalo?
No, actually, I'm in Alexandria. I teach in
Alexandria?
Yeah. No,
but are you?
I'm in the faculty in Buffalo. It's all online.
I see. Okay. And how are you doing? It's great to see you.
Very well, thank you.
I'm pleased to hear.
So it's very nice to hear the talk.
Are you still working and teaching?
Yeah.
Amazing.
I'm a full-time working faculty member at
That's
Information
wonderful.
Science Department. Yeah.
Great, congratulations. So very nice to see you.
No plans to retire.
Yes. I really remember our discussions about, hierarchies and categories and Library of Congress, cataloging systems.
Yes.
They were very influential in my thinking. So nice to see you. Okay, yep. I think I'm done. Ready to sign off? Okay. Bye for now.
Bye-bye.
Bye-bye.
All right.